Back to my math YouTube channel. I'm here with another example on integration by parts. So guys, so far I have shown you 4 examples. They were all different types of examples. Again, this is also going to be different than what we have seen previously. It has a lot of steps. So let us start working on it and then let us see what we have to do in order to finally evaluate this integral. Okay, so the first thing I want to make sure like we know what we have to do like when we see the problem. First we figure out like if there's any direct ways or shortcuts or substitution method that can help us to evaluate this integral. And I mean, if we go through all those methods, we won't be able to use them to actually evaluate this integral. They won't help us to evaluate this integral. Then we have to move on to new methods. The next method which we have learned is called the integration by parts method. The formula is already listed right here. And then we also know that we have to like also follow this this trick or this technique to like choose our f and g functions. Obviously, looking at these two, it's a product of an exponential and a trig function. So what comes first? Guys, the trig comes first before the exponential function. So that means we have to like a little bit like rearrange this. So we can rearrange or we can rewrite this as sine 4x and then times e to the power x. And then based on this, now we know we have to choose this first function, trig function, as my f function, and this I will choose as my g function. The exponential comes all the way at the end, right? We can see that here. Inverse, log, algebraic, trig, and exponential. Once we do that, then we already have the formula here, and we're just going to use that or apply that to this particular integral. So starting with the function f first, we just have to write that function sine of 4x, right? And then times the integral of the g of x. So I'm going to write, because I like to write all the steps, and I highly encourage everyone to write steps as well. So guys, integral of e to the x dx, that takes care of this piece, and then there's a minus, and I have an integral of in parentheses f prime. Probably that is something that we can do looking at the function f, which is sine of 4x. What is the derivative of sine function? The derivative of sine is the cosine function, but here one has to use the chain rule, which means you have to multiply by the derivative of the inner, and the inner here is 4x, so the derivative of that 4x will be simply 4. So you will get 4 times cosine of 4x, that would be the derivative of the f function, and then it's times the integral of the g function. We just have to we're not going to evaluate it right here, but we're just going to write that step, and then finally there's a dx right here as well. Okay, guys, that is kind of step number 1. Okay, just using or applying it to the actual integration by parts formula here. Now let us move on. This is still going to be sine of 4x. We can evaluate this, very pretty simple integral. It's just e to the power x. Right, it's just e to the power x. That takes care of this piece, and then minus. Well, there's so much going on here, but let's see what we can do. Guys, how about if we take just this 4 outside, because anyway, like the constant, we take it outside the integral, so we can take it outside. So let's take that outside. Then let us see what is left inside the parentheses. I have the cosine of 4x. We already know that we have to first simplify or evaluate the integral. We always go from the inner to the outer. And we can evaluate this integral. This is going to be times e to the x, and then there is this dx. Right? That is the step 2 here. Took that 4 outside, then this we just leave it like that, and we just evaluated that integral. Okay. Let us see what would be the next step now. So sine of 4x e to the x. These guys are just going to like carry along till the end, and then here let us see what we can do. Okay. Again, we have a product of 2, right? So we were like, by using the integration by parts, we were not able, well, I mean, we were able to simplify this piece, but we were not really able to do much with this piece. So, but what we can do here is, guys, looking at these two again, we have to ask ourselves, is there any shortcut? Is there any direct formula, or is the substitution method a good method to evaluate this integral? And it seems like none of those methods are going to work here. So again, one has to go back and use the integration by parts again. So basically in this example, now we're using the integration by parts twice instead of using it just once. Okay, but guys, there's something more with this problem. So that's why I chose this. It is different than all the other problems that we have seen so far. Okay, so it's going to be a lot of steps, but these are the kind of problems that we need to do when we are undertaking calculus 1 and calculus 2. Okay, so guys, this is already in the nice form because trig function takes the precedence over the exponential function. So this is my, I'm going to treat this as f and this as g again. And now again I have to follow the integration by parts formula. The negative 4 is still outside, and I'm going to draw a square bracket, and then I'm going to again use this formula. So first I have the f, which I just have to rewrite, cosine of 4x, then times integral of e to the x dx, okay, and then minus, I'm just using the formula here, then integral of, what do I have? I have the derivative of the cosine here, right, because f is cosine 4x, so derivative of cosine is negative sine 4x, but then I also have to multiply by that 4, which is the derivative of the inner, so it is going to be negative 4, right? Negative 4 sine 4x. And then we have to multiply this by the integral of e to the x dx. Of course, there is another dx outside. Okay, this is, this, oh, I started that square bracket, so I should better close it as well. Okay, so that simplifies this. Let us see what we can do now in the next step. So we have sine 4x, e to the x, guys, negative 4. I'm still going to leave that negative 4 outside. I'm going to try to simplify the pieces inside these square brackets, and there's a lot to work with, okay? Guys, the integral of e to the x is e to the x, so I can just write it like e to the x cosine 4x, okay? I just rearranged. Probably I should have actually rearranged this as well. Maybe we'll do it in the next step. Guys, it does not really matter, but usually we like to write the exponential function first and then the trig function, but it does not really matter that much. Now let us work through this step carefully. Again, what I'm going to do is this negative times negative is going to become positive. So why don't we just change it to positive, because it's like easier to work with positive quantities. Then guys, this 4 is multiplied throughout, right? So I can also take out that 4 outside. That's what we do with the constants when we are trying to find the integrals. Now let us see what we can do here after we take that out. Then I have a sine of 4x. We don't do anything with it yet. All I do first is I do the integral of the inner here, which is integral of the e to the x, which is just e to the x. And then there is a dx. Okay, of course we have to close the square brackets. So guys, it seems like things are just like repeating here. We wanted to evaluate this integral of this function, and we got, well, this half piece is fine, we were able to simplify, but then the other half, from here we got to the cosine, well, e to the x is still there, but then now it is alternating between cosine and sine, and now when I go to this next step, again, the first half was fine, we still were able to evaluate that, but then here, it just like now we're getting back that sine. And if you look at this integral carefully, I mean, it looks exactly like what we are trying to evaluate. So it is like alternating between sine and cosine, because even this is something that we cannot just evaluate directly. I mean, if we were able to do it, then we would not have even actually tried setting this whole thing up. So again, it's like we may want to use the integration by parts, but it does not make any sense to use integration by parts again on this guy, because this is the same guy that we started with, right? So if we start doing that again over here, we will still again get all these steps again. So we'll get a cosine in the integral times the e to the x, then it will, again, we won't be able to evaluate that, then we'll do it again. So it will not make any sense to keep on repeating this integration by parts method over and over again. But guys, this is something that is different about this particular example. Now, what is unique about this thing is that we want to evaluate the integral of this, and now it is on the right hand side. Okay, so once we get that same integral that we are starting with on the right hand side in any form, like in this case it is multiplied by 4 and then also multiplied by that negative 4, that does not matter. Once you just stop right there, and then I'll show you like how we can simplify this further. Guys, the main part of this problem, the main work for this problem is almost done. We just have to do like few more steps to get the final answer for this integral, okay? So it may not be so clear if you have not seen these type of examples before. At this point, you may be wondering how we can still evaluate it. Guys, I need some more room to show you how we can do it, but trust me, the main part of the problem is done. We just have to rearrange few things and we'll be able to get the integral, okay? So what I'm going to do is I'm going to get rid of this whole thing. We need space. Okay, so here I'm going to get rid of this. And from here we're going back. So this, let's go back here. I'm going to, maybe you know what, let us squeeze this in here. I'll try to squeeze it in this. And actually I would want it to be in like one straight line, in one line, okay? So this guy, guys, I'm going to rearrange this a little bit. So I'm going to write e to the x sine of 4x, okay? And then what I'm going to do is I'm going to start by distributing this negative 4, okay? So it's going to be minus 4 e to the x cosine of 4x, right? And then I got to distribute that with this guy as well, so it will become minus 16. And then I still have an integral of sine 4x e to the x dx. Okay, actually I wanted it in just one line, so that's nice that I was able to squeeze it in one line. Guys, here's the thing. This quantity that we are trying to evaluate the integral for and this, they are the same, right? So you can also think of these as like terms, as you would do in with simple algebra or with simple functions. Same thing you can use for these integrals as well. If there are like terms, you got to combine them, whether it's algebraic functions, trig functions, exponential functions, or functions with integrals or functions with derivatives. If they're like terms, you got to combine them. So what we can do here is I can add 16 and this whole quantity to both sides. What I'm trying to do is I'm trying to combine these things. So if I add to this side, it will cross out, but I also got to add it to this left hand side as well. So I'm going to add it right here as well. Integral. Guys, that is something that you would do for any algebraic equation if you want to combine the like terms, or if you want to solve for a particular variable or particular piece, you would want to bring it to one side and you would want to bring everything else on the other side. That's exactly what we are doing here. Okay, so plus 16, this one is plus 16 integral of the same thing, sine 4x e to the x dx. So on this side, these things are going to cross out, right? On the left hand side, guys, there's like an invisible 1 here and there's a 16 here. These two are identical, they are like terms. So what can you do here? You can just combine them. That was the trick. That was like the most important thing in this particular example, that when you reach to this step where you get that sine 4x dx, which looks exactly like where we started with, you got to stop right there. You got to simplify this like we did, and then you got to bring it to the other side so that you can combine those like terms. And when I combine these two, 16 plus 1 gives me 17. And then I have this integral of e to the x sine 4x e to the x dx. Okay, all we have to do when we combine is we have to just add these constants, 16 and 1. This stays like that. It's like if I have a 16x and 1x. So I just add 16 plus 1, 17, and then x stays, right? So same thing here. There's an integral piece here. This is the same. They look alike. You just have to add those constants outside, and then the integral stays as it is. And on the right hand side, nothing changes except for this goes away, and you're only left with this e to the power x sine 4x and minus 4e to the x cosine of 4x, right? From this, I'm not interested in 17 times this. All I want is to evaluate this integral, or when we rearranged, it's just this integral. So if I just simply want this, the value for this integral, so it's like if I have 17 times x equals to this, and I just want to evaluate the x, you would just divide both sides by 17, right? So you would do the exact same thing here as well. You ought to divide both sides by 17, because that will cross, 17s will cross out, and on the right hand side you will have to divide by 17 as well. So that's it, guys. Let me actually get rid of this last thing, and so that we can write the final answer in a more nicer way. So finally the integral, the final answer for the integral. So I'm going to rearrange it back like the original form, e to the x sine 4x. Keep in mind this and this are exactly identical, it's just rearranging things. So this is what we wanted to evaluate in the first place, but we rearranged based on this fact that the trig function takes the precedence over the exponential function, all that, and then once we did all that, this finally is equal to, if you like, you can break it down. Guys, you can leave it like that, that is fine, or you can break it down as 1 over 17 e to the x sine 4x, and then minus 4 over 17, because this 17 divides the first piece or first term as well as the other term, second term. So 4 over 17 e to the x cosine 4x, and then since we are still, this is still an indefinite integral, so I got to have a plus constant of integration. Guys, this is a lot of work, but I mean, you have to work through these type of examples, and I wanted to take this opportunity to actually share with you and show you one of those types where you may feel like this is like a never-ending process, but you got to stop at some point of time, and then you got to like rearrange things, and then you will be able to evaluate the integral. Guys, this is example 5. I will see you next time in my next video with example 6. In example 6, I want to do something with definite integrals using still the integration by parts method. Okay, guys, please keep on working on these examples. That's the only way one can like really get confident with doing and solving these integrals. Okay, practice more problems on integration.